Thank you. Good evening, everybody. I'm going to share with you on the latest development of the retractable noise barrier. This is an invention. It is jointly developed by Wilson Acoustic and Acoustic Innovation. Why we have acoustic innovation? Because during the R&D process, we found that the job nature of the R&D is very different from the consultant service. So we found that in order to make an efficient development, we need to set up another company in order to develop such a product. Okay, let us start. This is not asking you to SilentUP. This is the name of the noise barrier. Because this noise barrier is silently upward, we can install the noise barrier very silently. So we call it SilentUP, like this. So SilentUP is actually, if you type retractable noise barrier in Google or Yahoo or any search engine, that is the only one appear in the entire internet. So I could not find any other country have such a retractable noise barrier. So you can see a few YouTube, and this is from our company showing how the retractable noise barrier. Okay, a normal conventional noise barrier is 3 to 6 meter height, subject to the foundation conditions. Concrete foundation and steel structure is normally required because for the wind loading of 1.2 kilopascal, that is quite high. That is actually is around 150 kph. So normally the noise barrier need to design for a wind loading of 150 kph because it is ensured it will not fall down. So such that large machine required for the installation. And the other type of noise barrier called movable noise barrier is some kind of misconcept. Movable, you cannot move without a machine. It is, although it's slightly lower, it's 2 to 4 meter height, and it still need a heavy base, but it is still as heavy a half ton. You need a crane to move it. So whether this barrier is enough for various site conditions in Hong Kong, let's see a few examples. This is one of the examples. The water supply department doing a water pipe replacement. On one side there is this is the pedestrian walkway. On the other side is a operation road. There is no space for putting the conventional noise barrier or even movable noise barrier. There's no space to put the movable noise barrier. And also, you cannot imagine how a crane can be accessed this location. If they need to put a crane, probably they need to put in this side, and then the entire road will be brought up. So then they need some kind of new type of noise barrier in order to screen the construction work. Another example, if some construction work underneath a podium, then this should be good enough, but there is an opening. The opening is also a car access road. Although this road is only used a few times a month for the material delivery, but if a conventional noise barrier built there, it do not allow because the car need to go in and out. So they need to build a door. The third type example I call it Sunday barrier. Sunday is happy day, but for construction work, some of construction work they need to carry out continuous 7 days. On Sunday they need a specific barrier because some activity they need a barrier. For example, in this case is rubble handling. Handling of rubble is considered as the prescribed construction work, so they need a barrier to screen it. So if they build a barrier to surround this activity, it will block up the site access road and slow down the site activity. So they do not allow to build a barrier on daytime or on the weekday. Okay, it is clear that there is many other examples. We need a new type of barrier. What is it? It could be quick and fast installation, don't need to do any foundation work, structure will not fail during the occasional gusts. And then good sign insulation, because the barrier, normally the barrier panel is very good sign insulation. The problem is the interface gap. How to seal up the gap is very important when you're making a barrier. And then easy transportable. So whether we can make it, we make it. So we call it retractable noise barrier. This is the first one in the world. Okay, let us quantify the requirement. It should be at least 3 to 6 meter high, same as the conventional noise barrier. The insertion loss should be more than 15 dBA for the prescribed construction work requirement. Also, it should be very quiet such that it can be built after 7 p.m. because after 7 p.m. there is a noise control ordinance and require all the PME, the machine is not allowed to use. So then we make our design. As we have this idea for a few years. So when we make the design, we make much better than this requirement. We try to make 8 meter high noise barrier, and the panel installation is more than 18 dBA reduction. And we are very quiet process such that only the major noise is speaking. So if the worker do not speak, then it will be very quiet. We don't need a machine. The interface gap we are designed with automatic sealing, so ensure all the panel will be automatic seal up to a good position. And also the all components are designed to be less than 10 kilogram, except the water barrier base, it is about 15 kilogram. And then the panel surface density, we want to minimize it. At the moment, we are at 5 kg per meter square and 3 kg per meter square. We are still want to minimize the panel's weight, but do not sacrifice the noise insulation. Also, the lightweight, safety concern, low cost, user-friendly, durability, all this need to be concerned. Okay, when we consider the entire design, we find that the wind loading is the most critical factor. We must solve the wind loading process. Okay, let us see some video. I hope this video well. Is it? How can I? Okay, this is the first prototype. We try to verify whether the automatic sealing is working. So you can see when the panel going up, the upper side of the panel can be automatically sealed up to the pole, and the other panel can be automatically sealed up to the adjacent panel. You can see we are using a metal frame at the bottom. This metal frame is the grid ups quite a lot of problem because this metal frame, we need a lot of counterweight. The counterweight for this barrier, if we need to make reasonable stability, we need 300 kilogram of counterweight in order to make this barrier to a reasonable stable. So it makes a lot of problem if we using a metal frame foundation, metal frame based structure. Then we have another one. Okay, kick on. Okay, this is an we allow using water barrier. The installation time is actually less than 10 minutes. When the next day we do it again. This is the acoustic mat, and then they put a 5 meter, 6 meter high carbon fiber tube. up the panel from ground level, so we don't need a machine to make a high barrier. Then there is an automatic shield at the top. This is actually a demonstration witnessed by our client Leighton, the MTR, and the authority EPD. So we did an insertion loss test. The result is better than 23 dBA. So with this noise barrier, the noise level reduced. We have a few measurement locations. One measurement location has 26 dB reduction, and the second one is 23 dB. So we take 23 dB as